Humans on the moon. What is the strangest thing found there? Not aliens, nor bases, but something that shouldn't exist. With the unveiling of our manned lunar lander, this discovery becomes critically important. Since more than 50 years ago, when the Apollo astronauts last set foot on the moon, more than half a century has passed. No human footprint has touched that land again. But dozens of probes have been sent there since. Some successfully landed, some performed flybys, and some were intentionally crashed into the moon, just to see what kind of impact it would create. In general, the moon is the most studied and observed celestial body by humans, but even after decades of research, the moon is still full of mysteries. Whether it's the way it stores heat, or the principles by which it conducts electricity, or even the properties of its soil, we still know too little. The universe seems to be like this. The more we study, the more questions we find. For example, before obtaining lunar soil, we were full of expectations. But after the lunar soil was returned, a series of discoveries of chemical traces that shouldn't exist left scientists scratching their heads for the following decades. You might think a scientific discovery would immediately change everything, but the real process of science is very slow. Sometimes, even when everyone notices it, no one believes it. This story begins in 1976. At that time, the Soviet Union launched an unmanned probe to the moon called Luna 24. This was their last mission, to collect lunar soil. At the time, no one paid much attention to this mission. It wasn't the first, and its scale was not large, but it quietly accomplished something significant. It drilled about 2 meters below the lunar surface, extracted a small core of lunar soil, and sent it back to Earth. This sample weighed only 170 grams, about the size of a baseball. Although not much, within this narrow tube of dust, something strange appeared. A trace of water. About 0.1% of the sample contained water. And the deeper you studied the sample, the more water you found. This should have been a major discovery. But on the contrary, scientists thought this water might have come from Earth, that the sample was contaminated, perhaps from the lander, or perhaps from equipment on Earth, because textbooks clearly stated that the moon is dry, and it's impossible for it to have water. And this wasn't the first time. Previously, in the soil brought back by the American Apollo astronauts, there were similar signals of hydrogen, but they were also dismissed as contamination. Thus, these clues, which should have caused a sensation, were left to gather dust in the corners of lab reports for decades, never to be mentioned again. It wasn't until the turn of the century that people started to realize that we might have missed something important. But by the time we were ready to go back and take a closer look, the moon was already prepared to present us with more puzzles. If you were dropped at the lunar poles, on the edge of some craters, you would see an almost unnatural sight. Not because of what's there, but because of what's not there. Not even light. Only a permanent shadow that has not moved for billions of years. These areas are called permanently shadowed regions. Why is this so? Because the moon stands very upright. Its axial tilt is only about 1.5 degrees. This means, when sunlight shines on the poles, the light rays are almost horizontal to the lunar surface. The craters are large and deep, and sunlight cannot reach inside. So that place, throughout the history of the solar system, has almost never seen a single ray of sunlight. Not only is it cold, there's no thermal cycle. The coldest places among them can reach below minus 240 degrees Celsius. This is colder than the distant Pluto. It can be said to be the coldest place in the solar system. Scientists began to wonder in the 1990s if comets or asteroids had ever impacted the moon, bringing water with them. Could some of the water vapor have drifted into these craters and been frozen, never to leave again? This idea immediately caught on, because it meant the moon might not be just a dead rock. It could be a resource depot, a future refueling station. From then on, all eyes were focused on the lunar poles. Viewing from Earth was no longer enough. We had to get closer for a better look. But the problem is, these most promising places are also the hardest to get to. The terrain is complex and there's no light. Solar panels are useless there. But the temptation was too great. What if there really is ice? So wave after wave of exploratory missions set off with one goal: to find concrete evidence. And just then, things started to get strange again. Scientists suspected there was ice there. So what was the next step? Send a scout to take a look, of course. But a direct landing was too risky. So the first few missions were all about orbiting and observing from above. The first was NASA's Clementine, launched in 1994. It wasn't looking for water. Its main purpose was to map most of the lunar surface. And it confirmed that the South Pole indeed has those large, permanently shadowed craters. But it didn't carry the right instruments. So it couldn't confirm if there was actually ice in the shadows. Then in 1998, NASA launched the Lunar Prospector. This time, the goal was to find water. It scanned the moon with a special instrument. And as a result, at the poles, especially in those shadowed regions, it found large signals of hydrogen. This made the scientists ecstatic. Theoretical estimates suggested that the ice reserves there could be in the tens of millions, or even hundreds of millions of tons. This wasn't just a puddle of water. It was a discovery that could change the global landscape. But then another problem arose. Discovering hydrogen is not the same as discovering water. It could also be part of hydroxyl, or locked within minerals. The instrument couldn't distinguish between them. It could only tell us there was hydrogen-containing material there, but it couldn't confirm if this hydrogen was part of water ice. So what was it? Actually, even if it was water, an orbiter couldn't see it. So it wasn't considered concrete evidence at all. This once again left the scientific community scratching their heads. There was data, there were clues, but no final confirmation. It was like the moon telling you it has a treasure, but not letting you see it. So scientists thought, since we can't see clearly from orbit, let's just be direct. Let's just crash into it. You heard me right. Crash into the moon. The logic is simple. If ice is hidden at the bottom of a crater, and I can't see it from above, then I'll just hit it hard with something. Blast out the contents of the crater floor. And when they fly into a sunlit area, I'll be able to see them clearly, right? This method is simple and crude, but effective. The first attempt came from the Lunar Prospector. After completing its mapping mission, in 1999, it crashed into a crater near the lunar South Pole. But unfortunately, this attempt failed. No water was detected. The results of the experiment were inconclusive. Some said the impact angle was wrong. Others said the impact was too light. 10 years after the failed impact detection, in 2009, NASA's LCROSS mission brought a breakthrough. This time, they played a clever trick. It brought along a Pathfinder, the upper stage of the rocket that launched it. It first used this large piece of metal like a projectile, smashing it into a crater near the South Pole named Cabeus. A few minutes later, the LCROSS satellite itself followed the same trajectory, flying directly through the debris plume created by the impact. For on-site analysis, this time it was successful. The onboard instruments detected water vapor in the plume. This time it wasn't a hint, but real, measurable water. Not only was there water, but also methane, ammonia, and other substances. This was the first time humans had truly and tangibly found water on the moon. Headlines all over the world reported this event. Scientists celebrated with champagne, feeling that this decades-long puzzle was finally solved. But soon, new questions arose. The impact was successful, but how much water is actually there? Is it in solid blocks of ice? Or is it like icy sand mixed with soil? Most importantly, how easy is it to excavate? LCROSS gave us an answer, but it also disintegrated in the impact. It couldn't provide more information. We only know that there is water at least at that point. But the overall picture of the moon remains a mystery. All along, everyone's thinking has been quite direct. If the moon has water, it must be hidden in those coldest, darkest, permanently shadowed regions. Sunlight never reaches these places, making them like natural giant freezers. Ice could remain there for billions of years. This logic is sound, but the moon always has new tricks up its sleeve. Orbiting probes, like NASA's Lunar Reconnaissance Orbiter, which has been orbiting the moon since 2009, and India's Chandrayaan-1, began to detect faint signals of water molecules outside of these giant freezers on the sunlit lunar surface. This completely baffled everyone. Looking for water in places where the sun shines, the daytime temperature there can soar to over 100 degrees Celsius. Shouldn't the water have evaporated completely long ago? Even more perplexing things were to come. Scientists discovered that these water signals were not always present. They actually had a schedule. At high noon, when the sun is at its strongest and the surface is at its hottest, these water signals would weaken or even disappear entirely. But as evening approached and the ground cooled down, the signals would return. What is this called? Is the moon sweating? Sweating during the hot day and reabsorbing it at night? This phenomenon is completely mind-boggling. You have to remember that the moon is a vacuum environment with no atmosphere, no atmospheric pressure, and no wind, on Earth, rain, or lightning. Water evaporates and condenses, which is called the water cycle. But the moon is barren. Where would it get a water cycle from? This is definitely one of the top mysteries that the moon has thrown at us. So where does this water come from? Scientists, scratching their heads, came up with a few possibilities. One theory is that it was delivered by extraterrestrial visitors. Every day, countless micrometeoroids, like dust, impact the moon. They might carry a little water themselves. Or they might strike the minerals in the lunar regolith, releasing the water locked inside. Another more interesting theory is that it comes from the sun. The sun is constantly blowing outwards, a stream of charged hydrogen particles, which we commonly call the solar wind. When this wind hits the moon, the hydrogen particles collide with the oxygen in the lunar and synthesize water molecules on the spot, regardless of the source. This discovery completely changed the game. It means we might not have to go to those dark, extremely difficult to develop polar craters. Perhaps the entire lunar surface is thinly coated with a layer of moisture. It just depends on whether we have the ability to collect it. This instantly expanded the potential sites for future lunar bases by an infinite number of times. This enticing possibility directly spurred the next generation of exploration missions. And so in 2023, Indian scientists also took on this ultimate challenge, the Chandrayaan-3 lander, with its target being the South Pole, which scientists believe is the area with the highest concentration of frozen water. This was the first time humans had sent a probe to the South Pole. Everyone was watching with bated breath, waiting for the Progeny rover to send back news that it had found ice. Using both lasers and X-rays to analyze the soil on the ground. And the result? Aluminum, iron, calcium, silicon. Everything but hydrogen. No hydrogen means no water. Everyone was stunned. What about the promised water? It was clearly marked on the maps. Were we wrong all along? Or is the water hidden too deep, beyond the reach of the rover's small shovel? Before anyone could figure it out, the 14-day-long lunar night arrived. The temperature plummeted to over -100 degrees Celsius. Chandrayaan-3 did not survive. It fell into an eternal sleep. What it left us with is an even bigger mystery than before. However, Chandrayaan-3's journey was not in vain. Before its demise, it unintentionally discovered a key clue with a temperature probe. It measured the temperature of the lunar regolith and found that the surface, scorched by the sun, was a scorching 60+ degrees Celsius, but just 8 centimeters down. The temperature plummeted to -10 degrees Celsius. This temperature difference is too great. What does this mean? It means that the top layer of lunar soil acts like a thick insulating layer. The heat from the outside simply cannot penetrate. This perfectly explains why the rover found nothing on the surface. Because the water ice is likely hidden just a few centimeters below this down jacket, safe and sound. So it's very likely not that there is no water, but that our previous shovels were too short. So the question is no longer whether the moon is dry, but whether our tools are sharp enough to do the proper digging. If this is true, then the next lander will not need to fly further or see more clearly. It will just need a more powerful drill. For decades, the search for lunar water has been seen as a scientific curiosity, a way to better understand the moon's history, geology, and how water moves through the solar system. But this is no longer the main reason for the interest in it. Today, lunar water means something much more immediate. a stepping stone for humanity's ascent into space and the cornerstone of future space bases. Because if we can find usable water on the moon, enough to extract, purify, and store, it will unlock everything else. First, it makes long-term lunar missions possible. Water is heavy, and the cost of launching it from Earth is high. The water transported there is comparable to gold. But if astronauts can obtain water locally, it reduces the supplies they need to carry. This water can be used for drinking, cooking, cleaning, or cooling equipment, without relying on continuous resupply from Earth. Second, water can be broken down into hydrogen and oxygen, the same fuel combination used by many modern rockets. If we can build a system to extract water ice and convert it into propellant, then the moon becomes more than just a destination. It becomes a refueling station, a place where spacecraft can refuel before heading into deep space to Mars, asteroids, or beyond. This changes the entire calculation. Currently, each mission must carry from the start its fuel. But establishing a resource supply can lighten the load. Launching from the moon is also easier. Its gravity is only 1/6 of Earth's. This means less energy, lower costs, and greater flexibility. A spacecraft launching from the moon doesn't need a huge rocket. It just needs a push. Third, local water changes the way we build. It can support closed-loop life support systems, recycling waste into usable resources. It can even help grow food. Some plants can grow in lunar soil under controlled conditions, but they still need water. If we find enough water, future habitats may not be completely dependent on resupply missions, airdrops, or hydroponics. It can be said that this will have a pivotal role in the future of human space exploration. Although it is still uncertain how much water is available or how easy it is to access, because all these fuel depots, missions beyond the moon, can only be realized if we can first extract that water. This brings us to the final question. Despite so many missions, data, and optimism, the fact is, we still don't have a clear path whenever forward. We feel like we've figured out the moon, it throws something new at us. A contradictory reading, a missing signal, an unexpected result. And this pattern repeats itself over and over again. We see strong hydrogen signals from orbit, but no hydrogen in the soil upon landing. We find signs of water vapor in the impact plume, but no frost, no ice caps, no visible accumulation, even in craters that have never seen sunlight. Places cold enough for ice to remain frozen for billions of years. High-resolution cameras still haven't captured anything that clearly looks like ice. Instead, we get ambiguity. Shallow probes come up empty-handed. The water detected by instruments seems to disappear during the day. Rovers have driven through craters that should be filled with frozen material, only to find more dust. Even new technologies like the ShadowCam, though capable of imaging the darkest places on the moon, have yet to reveal the kind of clear, reflective ice sheets that scientists have been hoping for. This raises a disturbing question. What if we've been wrong all along about how the moon stores water? What if the models need to be revised? Or worse, what if the water does exist, but it's so thinly distributed, buried so deep, or so chemically bound to the soil, that we're not yet equipped to access it? Of course, on a more optimistic note, perhaps our tools, though precise, are still not good enough. Our orbiters are like eyes in the sky, seeing far but unable to touch. And our landers and rovers? They are like outstretched fingertips, able to touch but not drill deep. All our explorations have been like scratching. We always feel like we're just missing it. The spectral data sent back is also full of riddles. It tells us there is hydrogen here, but it doesn't say if this hydrogen is in water or in rocks. It tells us this area is bright, but it doesn't say if this brightness is from frost or some special kind of mineral. The word "give up" is not in humanity's dictionary. On the contrary, the more mysterious it is, the more our curiosity is ignited. New missions are lining up. More powerful landers are being built. And all eyes are still fixed on that place. The place we firmly believe holds a treasure. The next mission may carry a more advanced drill. It will have a deeper drill bit, a more intelligent extraction system. No more probing, but a once and for all breakthrough of that final barrier. From beneath that insulating lunar regolith, to scoop up a handful of cold, solid future. Of course, the moon may play another joke on us, leading us to discover even more unsolved mysteries. But when our drill finally scoops up that handful of cold, solid future, a new era, grander than the moon landing itself, will begin. By then, this will no longer be the cradle of civilization, but our harbor for venturing into the sea of stars. And when our drill finally scoops up that handful, a new era, grander than the moon landing itself, will begin. By then, this blue planet beneath our feet will no longer be the cradle of civilization, but our harbor for venturing into the sea of stars.